Okay, we're just going to look at a quick recap of last night's homework. So it was lesson 1, trapezoids. So we know here that we're given a trapezoid. It's an isosceles trapezoid since it tells us that AB is parallel to DC, but AD is congruent to BC. So when you see the opposite side there congruent, we know that it is isosceles. It gives us two sets of angles, A and C. Now, yesterday we learned that base angles would be congruent to each other, while the angles that were on top would also be congruent. And altogether, these two angles, though, they're not congruent, A and C. Instead, they're supplementary. Because if C is congruent to D, D and A would be supplementary. So that means to solve this one, we want to take 4x plus 20 and add it with 3x, subtract 15, and it should equal 180 degrees. And you could cheat a little bit, because if you look at the two angles, they don't even look the same. So not that you can ever write that as a valid reason, but since they don't look the same, we know we can't set them equal to each other. And then we'll get 7x plus 5 equal to 180. When we subtract 5 from both sides, we get 175. And when we divide 7, we will get 25. But we wanted to find the measure of angle D. So remember, D we marked as the same congruent piece as C. So we're going to plug 3 times 25 minus 15, and we'll get 75, subtract 15, and we will get 60 as our answer for number 1. For number 2, since we have a trapezoid, it's not an isosceles trapezoid, but we want to know which triangle would be equal in area to triangle RSV. So first, area of a triangle. Remember, we talked about this. It's 1/2 base times height. So let's go and highlight triangle RSV. We want a triangle that has the same base and the same height. There's only one that does follow those same restrictions. The same base and goes up the same amount has to be triangle RTS or RST. So choice 2. All the other ones are going to be slimmer in size or not have the same base, but that's why we're going to go with choice 2. In the diagram shown below, angle 1 is congruent to angle 2. Explain why the quadrilateral shown must be a trapezoid. Well, trapezoids have one property and only one property. They have at least one pair of opposite sides that are parallel. Think about what angles 1 and 2 are. Angles 1 being congruent to angle 2 make them alternate interior angles. And they are formed by parallel lines. So that being said, because we know those lines are parallel, that means RT and SU are parallel. And trapezoids have at least one pair of opposite sides parallel. Okay. In trapezoid MNPQ, we have the two sides MN and QP are parallel. We know the measure of angle M is 108 degrees. We know P is 4x, subtract 15, and we know Q is 3x, plus 21. And we want to show why we know that n must be 127 degrees. So first thing we know is that these two angles are supplementary because they're in between those parallel lines. So we have 3x plus 21 plus 108 equal to 180. When we combine like terms, we'll end up with 21 plus 108 is 129. And then we're going to subtract that 129 from both sides. So we'll get 3x equal to 51. And when we divide by 3, x is equal to 17. Now, that doesn't really show us why we know n must be 127. So what we can do is take that 17 and plug it in to p. Four times 17 is 68. Subtract 15 is going to be 53. And now, just like we started off the previous part of this problem, we know that n and p are supplementary. So 180 subtract 53 is going to get us 127 degrees. Now, that was great math skills, but we wouldn't get full credit on this question just yet because explain means we need words. So we want to explain the process. We want to explain exactly what happened, how we knew it. So I would say same side interior angles of a trapezoid are supplementary. That and the work that's shown would be enough to show us that 127, but we needed some kind of phrase to tell us that explain part. And the last one, we're given the quadrilateral. It's shown below already. Calculate the slope of each line segment and then simplify your answers. So remember, slope, nice thing about graphs is we just can count. So AB, we read it left to right, so it's going down 1, 2, 3, 4, 5, 6 over 4, which simplifies to negative 3 over 2. BC, we're going up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8. CD, we're going down 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Again, it's going to simplify to negative 3 over 2. And AD, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. What conclusions can you make about parallel sides of these slope calculations? Well, remember, parallel means it has the same slope. So if AB and CD are the same, they're opposite of each other. Just like AD and BC are opposite of each other. So we're going to say that opposite sides are parallel. What conclusions can you make about quadrilateral ABCD and why? Well, it's actually going to be our next type of quadrilateral we talk about. It's a parallelogram, and we'll learn more about that tomorrow.